number 9 here, we're looking at a sum in sigma notation. So this is a sum just like example number 8 of section 4. To find the sum of some number, right, however many terms we're adding, right, that's n, is a sub 1 minus a sub 1 times r raised to n all over 1 minus r. Or if you know what your a sub n is, you can take a sub 1 minus a sub n times r all over 1 minus r. So the only difference is that's being raised to that power there. So what we need from this, called sigma notation, and here, this right here is the Greek letter sum, or sigma, and it means repeated adding, right? So here our k is where we start. So that is where we start. So as if we start at 5, plug in 5, figure out what that is, that'd be our a sub 1. Then plug in 6, figure out that is, that's a sub 2. And keep going until I get to 12, plugging in 12. And that would be our last one, right? So if I do that, here would be a sub 3 would be plugging in 7, 8, 9, 10, 11, and a sub 8 would be 12, right? So that means that n I'm actually after is 8. So you can always figure that out, because normally how this sum thing works is you usually start at 1 and go to n. Okay, so then n would be the top number, but here, since we start out at 5, I got to know how far from 5 to 12 is. But if I subtract those, I get 7, right? So I need to add one more because I got to count 5, 6, 7, 8, 9, 10, 11, 12, which is 8 things total, right? So if you have a different number other than 1 here, then you need to go ahead and add 1 to that. So like here we go from 5 to 12, so 12 minus 5 is 7, and I need to add 1 to get to 8, because I got to count 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8. And we can kind of see that just like this. If I take n minus 1, that would be n minus 1, right? But my total number of terms is always n, so I need to add 1. So that's why I had to add 1 to this 7 here. Okay, so we want to find this right here. So n equals 8. Now we need to find a sub 1. Because we know our r is how are we going from the first term to the second? What is the repeated, either if it's an exponential, we know it's repeated multiplication, okay? If it is linear, then we know it's repeated addition or subtraction. All right, but this is an exponential because our base is -2, so that means our r is -2. And then we just need to find our a sub 1. Okay, so a sub 1, I can just plug in 5, and that'd be my k, right? So that's my first term. So I plug in 5. 5 minus 1 is 4. -2 to the 4th, 16. 16 times 3 is 48. So that means a sub 1 equals 48. Now I can use the formula back in example number 8. My n equals 8, because that's how many from 5 to 12 is. Okay, and then 48, my a sub 1 minus my a sub 1, times r, which is -2, raised to n, which is 8, all over 1 minus my r, which is -2. So that would be -2 to the 8 is 256. So 48 minus 48 times 256 over 3. And so now I can multiply that. -48 times 256, and then add 48, and then divide by 3, and I get -4080. So that is the sum of my 8 terms from 5 to 12.